This is Math 3, Unit 10, Worksheet 5, and I'm going to go over a few of the problems. Number 1 through 18, we're asked to sketch each angle in standard position, identify the quadrant for the terminating ray. However, if it's a quadrantal, identify the two quadrants it's between, and C, identify the reference angle. However, if it's quadrantal, identify it as such. So number 1, we have theta is 3 pi over 5, and now we're working in radians, not in degrees. So I'm going to first work in doing this. We have 0 radians and 0 degrees at the same location. We move around counterclockwise in the positive direction, and we need to remember that pi radians is equal to 180 degrees. So half circle, 180 degrees, we got pi radians right over here. So I just label the x-axis on the right and on the left. And then I take note, we're working with 3 pi over 5. Usually when we're working with radians, we're working with a fraction. And so I want to rewrite, right now we have pi over 1. I want to rewrite it as a fraction with a common denominator of the angle we're after. So if I multiply top and bottom by 5, I get 5 pi over 5. Which is the same thing as pi if we reduce that, but now we have a common denominator, 5 pi over 5. So 3 pi over 5 is less than 5 pi over 5, but 3 is closer to 5 than it is to 0, so we know this we're going to be somewhere in quadrant 2. So we're in quadrant 2, and then our reference angle is the difference between 3 pi over 5 and 5 pi over 5. Well, 5 minus 3 is 2, so we get 2 pi over 5 is our reference angle. Let's try this again with number 3. So 0 degrees, also 0 radians at that location. Moving counterclockwise, we have pi radians, but I want a common denominator, which is 18 to our angle that we're after. So this is multiply top and bottom by 18, and I get 18 pi over 18. So now I gotta find the location of 5 pi over 18. Well, that's less than 18 pi over 18, so it's going to be either in quadrant 1 or quadrant 2. And 5 is closer to 0 than it is to 18, so we're working in quadrant 1. And the reference angle here is the difference between 5 pi over 18 and 0, which is just 5 pi over 18 again. So our quadrant 1 and 5 pi over 18. Number 5, 3 pi over 2, where we have 0 radians, and then we have pi radians, but the denominator is 2, so this is really 2 pi over 2 as well. And so we've gone 1 pi, and then we can go back. 2 180s is 360, so this is 2 pi. But that's 2 pi over 1, and I want to work with something over 2. So I'm going to multiply top and bottom by 2, and I end up with 4 pi over 2. Moving counterclockwise, 3 pi over 2 is right in between 2 pi over 2 and 4 pi over 2, exactly in between. So it's not going to be in quadrant 3. It's not going to be in quadrant 4. It's going to be right in between them, pointed down, pointed south, where the 270-degree mark would be. So we have 3 pi over 2 right here. So if we look at our instructions, we call that a quadrantal angle, and it says to identify the two quadrants it's in between. So we're going to say between quadrant 3 and 4. And the reference angle, again, in this case, we just label it as quadrantal. I'll do one more with you on like this. Let's take a look at 15. Got 5 pi over 8. Here's 0. Here's pi over 1, but if I multiply top and bottom by 8, I get 8 pi over 8. So 5 pi over 8, well, halfway would be 4 pi over 8, right? And so 5 pi over 8 is going to be pointed somewhere around here in quadrant 2. And the reference angle is the difference between 8 pi over 8 and 5 pi over 8. So if we subtract them, we end up with 3 pi over 8. On number 19 to 24, we're to find the complement for each angle and find the supplement for each angle. A complement, or complementary angles are two angles that add up to 90 degrees. Supplementary angles are two angles that add up to 180 degrees. So let's take a look at 19. Let's keep in mind pi radians is equal to 180 degrees. And so if we cut each of those in half, we end up with 90 degrees is pi over 2 radians. Okay, so if I want to find the complement for 19, we have 2 pi over 5 plus something, which is our complement, is going to add up to 90, which is pi over 2. So I'm going to subtract 2 pi over 5, and we get our complement is pi over 2 minus 2 pi over 5. We need a common denominator if we're going to subtract. So first fraction, I multiply top and bottom by 5, and I get 5 pi over 10. Second fraction, I multiply by 2, top and bottom, and I get minus 4 pi over 10. And so the complement is going to be pi over 10, because 5 minus 4 is 1, and we get 1 pi over 10. For the supplement, we're going to do the same thing, and instead of setting it equal to pi over 2, we're going to set it equal to pi. So we're going to say 2 pi over 5 plus y is equal to pi. Two angles that add up to 180 degrees. Subtract 2 pi over 5, we end up with y is 5 pi over 5, that's our pi, minus 2 pi over 5, which is 3 pi over 5. And we found the complement and the supplement for number 19. For number 23, do the same thing. Pi over 4 plus the complement is equal to 90 degrees, which is pi over 2, 180 over 2. Subtract pi over 4, but I need a common denominator, so I'm going to change this for the pi over 2 to 2 pi over 4 minus pi over 4, and we end up with pi over 4. For the supplement, so I'm running out of room here, I'll put it right here. Pi over 4 plus our supplement is equal to pi. Subtract pi over 4. I'm going to change pi to 4 pi over 4 minus pi over 4, and when I subtract them I end up with 3 pi over 4. For 25 to 30, we're to find a positive coterminal angle and a negative coterminal angle. We did this, I think, in the second worksheet, if I remember correctly, and what we did with working with degrees is we would add or subtract 360 degrees. Well, if pi is 180 degrees, then 360 degrees would be the same as 2 pi. And so we're just going to either add or subtract 2 pi, and we'll end up with a coterminal angle. So on 25, if I take 7 pi over 4 and add 2 pi, I will get a coterminal angle. Again, when you're adding, you need a common denominator here because we're working with fractions. So this is the same thing as 7 pi over 4 plus 8 pi over 4. I multiply top and bottom by 4 because it was 2 pi over 1. And that's going to give us 15 pi over 4. And that's another positive coterminal angle, meaning that their terminal sides point in the same exact direction. For the negative, I'm going to subtract 2 pi. So we have 7 pi over 4 minus 2 pi. So we're just spinning around a full circle the other direction. And so get a common denominator. 7 pi over 4 minus 8 pi over 4 is negative 1 pi over 4. And we have a negative coterminal angle. We'll do that one more time with number 29. For the positive, I'm going to take 11 pi over 6 and add 360 degrees, which in radians would be 2 pi. Need a common denominator, so 11 pi over 6 plus multiply top and bottom of the 2 pi over 1 by 6, and you get 12 pi over 6. So we end up with 23 pi over 6. To get a negative coterminal angle, we'll start with 11 pi over 6, and this time subtract 2 pi. So 11 pi over 6 minus 12 pi over 6 is going to equal negative 1 pi over 6. And there we have it. For 31 to 33, it says review, find the ordered pair on the unit circle for each angle. So for 31, 315 degrees is in quadrant 4, so they're only showing us quadrant 4 because remember this is pointed down at 270, this is at 360, and so 315 is right in between, with a reference angle. The difference between 360 and 315 is 45 degrees. So we end up with this 45, 45, 90 angle. Now it says it's on the unit circle, so our hypotenuse here is 1. And so we need to find out what our x value is, which is the length, the horizontal length, and we need to find out what our y value is, which is our vertical length, and put those together in a point form, and we'll get our x and y values. Well, our 45, 45, 90 triangle that we tend to work with is we make both of these sides 1, and we make the hypotenuse the square root of 2. And so this is actually a larger version of the 45, 45, 90 that we have drawn in here. It's they're both similar by angle similarity, but one is scaled down. And so we could do that. We could take ours and scale it down. If I divide each of these numbers, or multiply each by 1 over root 2, or divide by square root of 2, then I scale that down to a hypotenuse of 1, and each side length is 1 over root 2. And you remember 1 over root 2, we could rationalize the denominator by multiplying top and bottom by root 2, and so we could write that as root 2 over 2. And so that is the exact triangle we're working with here. It's a 45, 45, 90 with a hypotenuse of 1, so we know both x and y are going to be root 2 over 2. So another way we can think about this, on the unit circle, remember we said x is the cosine of theta and y is the sine of theta. And if we just use our 45, 45, 90 right triangle that we tend to use, which I'm going to redraw here. Okay, here's our 45-degree angle, our reference angle that we're working with in quadrant 3, hypotenuse, sorry, I'm not drawing the same one, this would be root 2, this is 1 and 1, right? Then the cosine of that angle is adjacent over hypotenuse, which we get 1 over root 2. And the sine is the opposite of our hypotenuse, which we get 1 over root 2. And we get the same answers, because when we rationalize these, we get root 2 over 2, root 2 over 2, and those are our x and y values. Now we need to be careful. There's one thing I have not done, and that's respect the quadrant we're in. We're in quadrant 4, and all y values are negative in quadrant 4, and so we need to make sure we make that y value negative. And now we're done. So there's a couple different ways to think about number 31, and I went over both of those ways. Pick one way that you feel comfortable with. For number 33, again, we're looking for this coordinate, xy coordinate. We know one of them. We know the y value is 15 over 17. We don't know the x value. We have this right triangle here, and we can come up with the x value by using the quadratic formula. So we could say that x squared plus 15 over 17 squared equals 1 squared. 15 squared is 225. 17 squared is 289. It should be a plus sign, not an equal sign. Equals 1 squared, which is 1. But I see I have a fraction, so instead of writing a 1, I'm going to write 289 over 289. Subtract 225 from 289. We end up with x squared is 64 over 289. And then when we take the square root, we end up with x is, could be positive or negative, square root of 64 over 289, which is positive or negative 8 over 17. And we need to decide, should x be positive or negative? Well, we're in quadrant 2 in this picture on number 33, and x is always negative in quadrant 2, so we need to go with x is negative 8 over 17. So we put our coordinate together, xy is going to be negative 8 over 17, and y we said was 15 over 17.